Example number 2. Solve and verify. Now, these two questions are going to look very similar, but I think it would be best if you would see more examples. I think everybody would agree that they'd love to see more examples. If you don't need to see the second example, if you feel like you got it, don't worry about watching the second half of the video. Just ensure that you have the first one watched, and you know that you can do the homework questions from there. So, A and B. The first one is going to be the square root of x plus 3. Okay, I'm going to make a definite endpoint there with my square root sign because I don't want the negative 1 or the minus 1 to be a part of it, equals x. So first things first, we want to isolate the radical. So I'm going to add 1 to both sides. So the square root of x plus 3 equals x plus 1. Now here is the tricky bit. Here's the part that that we kind of practiced in the beginning when we expanded our perfect squares. So I want to square this. We've done this before. Okay, so you know how to square that. That just becomes x plus 3. But when I square this binomial here, x plus 1, what I end up getting is a trinomial, x squared plus 2x plus 1. Now since we've done that extra practice, you'll know where I'm coming from with this and know how I can get from here to here very quickly. If you didn't quite get that, go back to the first video, rewatch it, and do some more questions on that on the worksheet that I gave. So now what I want to set is set one side equal to 0. So set one side equal to 0. Okay, so my x squared term is positive here, so why mess with that? I'm going to set this side equal to 0, so I can say x squared plus 2x minus x. Well, I can just write it out. 2x minus x plus 1 minus 3. X squared plus x minus 2. Now what I want to do is I want to factor. So I think about it, two numbers that multiply out to -1 and add up to, multiply out to -2 and add up to to positive 1. So I have x plus 2, x minus 1. So I know that my x equals -2 and x equals positive 1. Now, especially when radicals are involved, we need to verify our answers because extraneous roots can be created when we square radicals. So let's substitute, or let's verify x equals 1 because that's easiest. Left-hand side, right-hand side. So the original question here is the square root of x, which in this case is just going to be 1. 1 plus 3 minus 1. And the right-hand side is x, but I'm going to substitute in 1 because that's the solution we're verifying. The square root of 4 minus 1, 2 minus 1, 1. Left-hand side equals right-hand side. We're good. Woot woot. So we know that 1 is a solution. What happens when you try out x equals -2? I'm going to do the same thing. So instead of my 1 here, or my x, I'm going to say -2 plus 3 minus 1. And my right-hand side is going to be x, or in this case, -2. So I say the square root of -2 plus 3 is 1 minus 1. Square root of 1 is 1 minus 1 is 0. Woo! 0 does not equal -2. So x equaling negative 2 is not a solution. And because I'm keeping my eyes on the prize, which is the grade 12 provincial math exam, what I want to do is I want to go back up and cross out the solution that does not work. We need to show that we have disregarded that solution and that the final solution actually is just x equaling 1. Let's go over to see another example. I'm just going to keep it on the same video because it's a very similar sort of question. B part is 6 minus x. I'm going to make a definite endpoint there. Plus 4 equals x. So the first thing first is I want to isolate that radical. So this is the radical that I want to isolate. So I'm going to subtract 4 from both sides. Square root of 6 minus x equals x minus 4. I want to square this to get rid of the radical sign, but that means that I also want to square this. So I have 6 minus x equals x squared minus 8x plus 16. Now remember, from this step to this step, I can only go so fast. I can only do that really quickly because I've practiced expanding perfect square binomials. So I'm going to isolate I'm going to set one side equal to 0. I don't want to mess with this here, right? I have a positive leading coefficient here with the x squared. So I want to keep my x squared term positive. I mean, I could bring it over to the other side and then multiply all the way through to by a negative 1, but this just creates way less work for me. I want to say negative 8 or minus 8x plus x plus 16 minus 6. 0 equals x squared minus 7x plus 10. So two numbers that multiply out to 10. And add up to negative 7. I think we know that. X minus 5, x minus 2. So that means I have two solutions. I have x equals 5, and I have x equals 2. Verification time. So let's try out our x equals 2. Left-hand side, right-hand side. So when I go back to my original question here, which is all the way up here, I have the square root of 6 minus x, but x here is 2, so 2 plus 4. Right-hand side equals x, which in this case is 2. Square root of 4 plus 4. Square root of 4 is 2 plus 4 is 6. Ugh! 6 does not equal 2, so therefore I know that x equals 2 is not a solution. Let's substitute and see if x equals 5 is a solution. So the square root of 6 minus x, but in this case we're trying out 5, so 6 minus 5 plus 4 equals the right-hand side, which is x, which in this case is 5. So square root of 1 plus 4, 1 plus 4, 5. Ooh, left-hand side equals right-hand side. So we have actually verified that x equaling 5 is a solution.